So here's an oxidation reduction reaction that we just want to balance. First thing we need to do is assign oxidation numbers to every element. I know the oxygen is -2, which means the arsenic has to be +3, so the total's added to 0. You got a total of +6 and -6, that equals 0. Oxygen is -2, so the nitrogen has to be +5, because you have a total of -6 from the O, +5 would equal -1, the charge on the ion here. This hydrogen is +1, oxygen -2, so if you have -8 and +3, you end up with a +5 for the AS in the product. Nitrogen +2 and oxygen -2. We want to identify the elements that change oxidation numbers. Looks like the AS changes by 2 electrons. And every nitrogen that goes from a reactant to a product changes by 3 electrons. And the whole point is to make sure that your electrons are balanced. Well, you cannot have 2 electrons be lost if 3 are picked up. So to balance a 2 and a 3, the lowest common multiple is going to be 6 electrons. And to get 6, you need to have 2 of the nitrogen and 3 of the AS. Before we actually start writing those down, if I look, right here I want to have 3 ASs, but in my problem, I've got a subscript of a 2. Well, there's no way to get 3 ASs when you have an even number of the subscript, which means I'm going to eventually have to change this from 3 to 6. So if I have 6 ASs, that's really 12 electrons. 6 times 2 is 12. To get 12 electrons here, instead of 2, I would really have to have 4. So I'm going to put a 3 here, because 3 times 2 gives me 6 ASs. I'm going to put a 6 there. I need to put a 4 here for nitrogen and a 4 there. And now let's double check. If I look here, I've got a total of 6 ASs. 6 ASs. 6 times 2 is 12 electrons. For my nitrogen, I've got 4 nitrogen. 4 nitrogen. 4 times 3 is 12 electrons. So I know my electrons are balanced. Then I want to just balance the rest by inspection. If I compare my oxygens, I've got 9 plus 12 is 21 on the left. On the right, I've got 24 plus 4 is 28. This is an acidic solution, which allows me, if something is acidic, then we can either add water or H plus ions wherever we need. So to get 7 more oxygens, I really need to add 7 H2Os on the left side. So that brings my oxygen count up to 28. If I now check my hydrogens, on the left I have 7 times 2 is 14. And on the right I have 6 times 3, which is 18. So it looks like I need to add 4 more H pluses on the left also to get that up to 18. Now my electrons are balanced at 12 apiece. 12 were lost, 12 were gained. Every other element is balanced as well. I'm going to finish by writing what was oxidized. The element that was oxidized in this case is AS, because it went from 3 up to 5. It must have lost 2 electrons. The element reduced was the nitrogen. It went from 5 down to 2, which means it gained 3 electrons. The oxidizing agent is the reactant that contains the element that was reduced. So my oxidizing agent will be the NO3 minus, and the reducing agent will be the AS2O3. And that is balancing an oxidation reduction reaction.